Hello and welcome everyone back to my another tutorial. This time I'll show you how to work with my machine learning training utilities PyTorch wrapper. Well, actually, I decided to continue with my handwritten word recognition tutorial, and because I made one with TensorFlow, and right now I decided to make one with PyTorch. And I'll show you what are the differences when you train these two models. And basically, I'm not going into the theory or into the code very deep, but I'm mainly gonna introduce you how this wrapper works in PyTorch and how it might help us to make our life easier while training the PyTorch model, constructing the pipeline of the whole training process, augmenting, using metrics or callbacks, the same way as we use this in TensorFlow. And basically, let's jump in without wasting a lot of time, because if you are interested, you can jump simply to my code that we can find link in the video description, or you can jump into the text version tutorial. But basically, let's begin with the code overview. So as you can see, here is 8 of my tutorials, and I'm continuing to expand this. And when I'm making a tutorial, I'm improving my machine learning utilities package, adding some new functionality, fixing bugs, or etc. So basically, if you are new to the PyTorch, don't worry, everything is pretty easy, and I'll walk through the code so you could understand it. So first, let's look at the TensorFlow implementation, how we train it. So basically, what we do here, we import a lot of my packages from MLTU library that you can install from PyP. And mainly, what are we doing here? That we are importing a lot of TensorFlow callbacks. Then we use preprocessors that we need to read image. We use the transformers to resize image, pad image, label the image, and if you would like to, we can display the image while we are developing. And then we use some augmenters to make our model more robust to different images. That helps in training. So basically, I use the data provider CTC laws because recognize words, it requires to join different lengths of the label. For example, house or beach or the car, all these words have different length, and the CTC laws help us to cover this. And then I use model to ONNX to convert my train model to ONNX. Of course, a train logger, that's not necessary, but it simply logs the training process into the file. And I use a character word error rate metric to track the whole training process. But basically, that's not about it. So what we did here, we simply preprocess the dataset, and mainly the dataset I'm using is IAM words. Of course, the link to this dataset you can find on my text bench tutorial, but you don't need to worry about that because, well, mainly my script automatically downloads this dataset and puts it in the right directory where you need. You simply need to run this code. And basically what it does, it iterates through a whole dataset. Because this data has specific structure, so it had to have some specific preprocessing to know what's the label of image, and we need the path to image. And with these things add to the dataset. So this dataset has a list of lists, and one component in list has a dataset link and label of that, for example, image, what is shown in it. And we construct this kind of dataset. Then, of course, we need to construct the vocabulary. That's what different characters we have in our words. We collect all this information into vocabulary, and we need to know what is the maximum length of our word possible in this data set. This is necessary when we are constructing our neural network model, because, well, output shouldn't be shorter than our maximum length. That's the rule. And then I save everything into configurations. Here's my data provider that I construct from my dataset, list of lists. So basically it iterates while we are training. It's like a Python generator, nothing special. And I split this data provider into two splits, training and validation, added some augmentation techniques to the training dataset. Validation dataset doesn't need it. Then we constructed a model, train model. And well, that's pretty simple model. I'm not covering here, but you can get deeper if you want. Then I compiled it with an optimizer. I used Adam, CTC loss, and checked word error rate metrics, and I used 6 callbacks, and you'll see in PyTorch I'll use very similar callbacks as these ones, and then I simply called the fit function where I give it training data, validation data, I specify how many epochs I would like to train it, I specify the callbacks that tracks the whole training process, and then I specified workers. This is specific for fit function of our TensorFlow models. And yeah, and finally when it finishes training, I simply save the training and validation CSV files. So in the future, if I would like to train on the same dataset, I don't need to iterate it over and over. I simply give these files to my data provider and I have all the datasets I need. So that was with a TensorFlow. It's pretty simple and basic stuff what we did, and we trained a model that achieved checked error rate of 8% within all these words checked, or it might be 6, I don't remember right now, but it's pretty nice how it worked. So right now everything is pretty similar in PyTorch. You don't need to worry about many stuff with this wrapper I'm working on. And so let's go to train Torch, and as you can see, I import several stuff here, Torch and Optimizer, and mainly you need to install this summary package if you would like to see what's the architecture of your model. By default, PyTorch is not giving one, so it's another package that you need to install if you would like to, but if you don't, simply comment this out. And then I have here a wrapper for our TensorFlow models, and basically this is holding all the training pipeline. Then I import the CTC loss, data provider, similar as you have in TensorFlow, but this handles the multi-processing stuff, because we need to process data on threaded or multi-processed way to make it faster for us, not to have a bottleneck on this data provider. Then I import 2 different metrics, checked error and word error rate metrics. As you can see, before I joined them into one, but it's better practice to have them separate. And then yeah, I import the same callbacks. As you can see, these come from my ML2 package. These are with exact names as we had in TensorFlow to know the meaning of them, but they imported from different locations, so that's totally fine, and they are specific for PyTorch. And then I import the same image reader, resizer, labeler, padding stuff, augmentation techniques, and we'll use them in the training. And then I have here a model Py that where I have defined my network, I import it, and I have some configurations. This configuration simply specify the height, width of your image, the path of the model where it will be saved, the batch size, learning rate, training epochs, and it has a vocabulary. Well, it has basic stuff that we might need. So let's go back, and then we have this script, the same as we had before, that it downloads our dataset. In the same way it pre-processes this dataset, it iterates through, saves it to dataset, saves the vocabulary, saves the maximum length of a possible word length. And that's it. We simply prepare the dataset. You don't need to either worry about it, just to make sure that your dataset paths are correct and you have processed the dataset. And then we have model configurations exactly the same as in TensorFlow, and that's it. So now this is the data provider. That's a custom data provider made for PyTorch by me, and you will see that it works the same as in TensorFlow. It's a simple generator that pre-processes all things for us. And here I have an additional image show transformer. That's a helper function. You need to remove this if you are training stuff. I'll comment this before publishing it in the GitHub. And it will help us to see what our dataset has. As you may see, I'm doing this before image resizer, and I need to use one worker because it doesn't work as well with multiprocessing, So, I'm interested in data provider just to show you the images. So let's run this, and when we'll come to this data provider, and you'll see I'll try to iterate it, and you might see several examples from my dataset, what I'm used to train my model, and of course it will give us the label of it. So we are iterating this dataset here. So we'll give it a minute to load it. We have a lot of examples, as you can see, and here is one of the examples. It's A, it's move, it's to, stop, and here's the label, Mr. Gateswell, from, nominating, and etc. It has, as you can see, it has a lot of words, and this helper function helps us to view what are our data set, if it's correct or not. And that's simply a helper function. Don't use it while training. It will slow down dramatically the training process. So great, as you can see, we have a data set that we're gonna use to train our model. That's great. So let's stop it right now. I don't need this anymore, and I'll remove this iterator. I remove this worker. I don't need this, and I'll comment this function that shows the image. So here as well, I'm splitting the dataset into training and validation. That's cool. Adding some augmenters, exactly the same as I did in the TensorFlow. And now I'm constructing my network. And if you are familiar with TensorFlow, you already know how to construct the model there. And in PyTorch, it's different, but I try to construct exactly the same network as I did in TensorFlow in terms of architecture. So what I'm doing here, I'm using several residual blocks, 9 residual blocks, and then I use one LSTM layer, and I'll define a dropout and output linear layer. So basically, these all the layers we are using in our Torch model. And now, because Torch is different architecture, but we can achieve exactly the same results with it. So basically, as you know, it said, I'm not normalizing images in preprocessing. I decided to do this in model level. So simply I divide images by 255, and it will normalize images between 0 and 1 float number. And then I need to permute the image. So this means that when we are giving image from OpenCV into this kind of model, it comes the last batch, channel last. And this means that, for example, if we would look at the shape of image, it might be 550 by 200 by 3, and this 3 means that it's a channel. And TensorFlow operates, convolution networks operates that it should become first. So I transform this into a different shape, and now it becomes batch first. So for example, have batch of 8, then it's 8. Our images RGB images have 3 channels, so it will be 3, and then comes 50 and 200. And then we give these kind of images to our network when we process the forward network. And then we apply the reshape function, and this is necessary after convolution networks before feeding our model into LSTM, because it has to have less size. I mean, well, the shape should be different. And then we simply apply the linear layer, and at the end we apply the logarithmic softmax function. That's specifically necessary for PyTorch CTC loss that we implemented. So that's great. We implemented this kind of model, and it looks pretty fine. And exact architecture is very similar. It's hard to tell me if it's exactly the same, but I try to do this exactly the same. And then we define the CTC loss that necessary to have the what is the blank label. So blank is the padding token. For example, all our words should be the similar length. This is why we need to record what is the maximum length in our dataset. And basically, if we have 20 maximum length, and we have, for example, word on. So this means that it will pad this word with a blank token that will be later removed in the training process. So basically, that's not the magic. And if we'll come to this CTC loss, it's pretty simple loss. And I'm here pre-processing. Oh, I can remove this. It's not necessary. And yeah, and as you can see, here I have a blank, and I'm removing this blank from target length and remove this padding token. So it simply needs to be reshaped into necessary format, but you don't need to worry about this right now. Well, if you're gonna follow my tutorial, it's pretty understandable why I did and where and how I did these things. Well, it's pretty necessary. And this is the rule how we implement this PyTorch implementation. One of the critical is that output of the module should be logarithmic softmax. Then we reshape the output and yeah, that's it. And you might ask why I'm doing this on the model level, for example, normalizing, logarithmic softmax, and etc. I'm doing this because when we are deploying our model, for example, into ONNX, we don't need to worry anymore about image normalization, what channels it should come first, what transpose we need to do, and etc. We simply wanna read the image, resize it, for example, to specified shape, for example 32 by 128, and feed this to the model, and we would like to receive the answer. And the answer is logarithmic numbers that we apply the argmax function, and we simply transform our indexes to string characters, and we have the output. That's pretty it. And if we go further, there is a Adam optimizer, and I applied the learning rate from my configurations, and this is how it was defined. And then is the summary. As I said it here, it requires a specific function here, and we'll come to this later. So another function is pretty easy, that for example I have a GPU and I would like to train the model on GPU. So here I'm just simply placing my network on GPU, and if we would have a lot of GPUs, for example 3 or 4, and multiple GPUs, it's pretty easy how we define it. We define it networks, data parallel, and device IDs, and it will be splitted on multiple GPUs, but I don't want to do this right now. So, but remember, if you're training this on multiple GPUs, increase the batch size because it will increase the efficiency of the model. And then I'm using the early stopping callbacks the same way I use in the TensorFlow. So this means I'll be tracking the validation character error rate. And this metric is basically character error rate. This one, I also have word error rate metric. We'll come to this later. So then I'm saving the weights of the model with this callback. It saves the best model here on top of previous save space. And there is a TensorBoard callback that saves the loss, learning rate, everything you are interested. And then we have a reduced learning rate on plateau, and simply that will reduce learning rate when it's not improving. For example, patience it's 10, and we are tracking the not a loss but character error rate, and this will be used for that. And I'll show you everything. We'll come back to the TensorBoard of the logs. I will not show you how the model is training here right now because it took me a while, way longer than I thought to train this model, but I'll upload this on my Google Drive so you'll be able to download it and play around if you're interested. So let's continue. And then I have a vocabulary, and as you can see, this model on next callback, it's very useful because when we are saving Torch model on disk, it doesn't do this the same way as the TensorFlow. It's not compiled. It means it can be sent somewhere else and to use some kind of function to load the model and use it, because, well, it doesn't save the architecture, the blocks we were using in our network. It simply loads the weights and saves the weights. And when we convert our model to ONNX, it's already ready for production. We can pick this file and move it somewhere else, and etc. And I am having here a metadata, and that's a very useful function that, for example, when we are decoding our predictions, we need to know initial vocabulary on which our model was trained. And basically, when I have it saved on the model, I can extract this from the model. I simply load on the next model, and it already has this metadata and vocabulary that I use. I don't need any additional files. For that, that's a great functionality. And so then simply I have my network defined, and I use the model function, model object, that wraps all the training pipeline, and that handles the metrics, the callbacks, the losses, when to end the training, and etc. Well, everything we are interested. And as you can see, I'm using check error rate metric and word error. This is a specific metrics for text recognition from files, and this is way better than loss, because we know actual accuracy of our character predictions or word predictions. It's way better. So then I simply feed these generator data providers to my fit function, and it will start the training process here. It has a callbacks, well, it has everything we need. Reduce learning rate, model to ONNX, and we don't need to worry about this. It simply starts the training process and keeps on until it achieves the last epoch, or the callbacks works as early stopping or whatever callback you define. So that's pretty easy. And let's run this in the debug mode, and you'll see everything by yourself. So right now it's loading the dataset, but don't worry, we'll come here, and we don't need to. We want to see the summary, for example, of our model before starting the training. It will stop right here. And as you can see, here's the summary of my model, what architecture I define, how many parameters we have, what layers comes first and out, and etc. Well, one disadvantage is that we don't see the input to our model, but we already know what is the input because we define this into configurations. It's 2 by 128 and channels are 3, and this comes into the model. So that's pretty exciting. So yeah, as you can see, everything is just great. And if I'll continue with that, it will start the training process. So we can move on, and you'll see that it will start training and how it looks like. But I'll stop the training because I already trained the model, and I think you don't want to wait it to finish. And I definitely don't want to wait it to finish while recording. And as you can see, we can see the epoch, the loss, character error rate, and word error rate. That's crucial things in our training process, and that's amazing. As you can see, word error rate already started to decreasing, and that's amazing. And one difference is between TensorFlow and Torch within these metrics. In TensorFlow, we were not able to use some custom loops or NumPy or simple Python, and that was a critical part for me, because it's necessary to implement everything in TensorFlow, in tensors, and it's really hard, especially for beginners who start using the TensorFlow. And PyTorch is very flexible. We can detach output and target from the tensor and you use them as NumPy. As you can see, I'm using the argmax, and then I'm using for loops here. I'm converting them into the strings, and then simply I'm calculating the character error rate, and that's it. And I'm here appending this character error rate, and at the end of epoch, these kind of results are called. We return the results, save it into the memory, and then the reset is called to reset everything before starting another epoch. As you can see, it's pretty basic and it's really easy to do. And I wrote here to implement everything in Torch, but it's not necessary because it works pretty fast, because it's pretty simple tasks and doesn't require a lot of information. Basically, if it would be necessary to train this for several weeks, I of course believe that it would be necessary to implement everything in Torch in terms of efficiency, but right now we don't need to worry and we don't need to waste our time basically on this kind of metrics. And that's amazing how easy it is. And you might see that you don't need to worry about what's the training loop, when we call train, when we call evaluate, when we call stop. Everything is handled by these metrics and callbacks, and it's pretty basic. And this is what I missed when I was started working with PyTorch. And right now, as I have this kind of nice object developed, you might use it, and I might use it in my future projects, because we waste a lot of time while implementing these different metrics to track or callbacks, when to stop our training and etc. So I simply standardize it to use the same logic as it's used in TensorFlow. And right now we can use this PyTorch library with my kind of implementations, and that's amazing. What I love the most, because right now I see that it's to use a PyTorch, it's way easy. It's not surprising me why more and more people start to use it. So that's it. Okay, I'm not talking anymore about this. Let's stop this and let's look how my TensorBoard looks like. I have the models saved here. Where is my models? Models here, handwritten recognition, and well, I'm not sure which of these. Okay, this one. So we don't need to worry about this. This model, and here I have logs. So I will copy related path, TensorBoard log directory. Sorry for my mistakes. And here I paste my log directory, and let's look how it looks like. I open the Brave browser. Nice. And it should open the TensorBoard for me. Here it is. So as you can see, it's trained for a while, and there is my test and training of character error rate, loss, word error rate graphs, and learning rate. So as you can see, my scheduler of the learning rate worked, and each time for 10 epochs it wasn't improving, it was decreasing the learning rate until it wasn't able to improve anymore, and it simply stopped the training. And as you can see, how everything worked, and basically I'm not so interested into the loss, I'm more interested into the character error rate. So let's maximize this a little for us, and you might see that character error rate was improving over and over, but it took a lot of epochs. It took me a lot of time. So let's see. Oh yeah, it shows me how long it took me. As you can see, it took me 21 hours to train this model, but I did a mistake that I set the learning rate too small, and it was pretty training a little way longer. It was possible to train it at least 2 or 3 times faster, and then I did it. But when I started, I didn't want to stop it. So yeah, cool. We can see the metrics, and the character error rate is 12. That's nice. Cool. We don't need to worry about this. So training was a little higher. That's the goal. And there's loss and test of the word error rate. It's slightly higher, but everything looks pretty fine and I'm happy about the results. So I believe you would like to see basically how it works, how to run the inference of this model, how to test this out. So here I have an inference model script. So basically I have here my validation CSV file that I saved saved validation this file when my training finished, and we'll use it not to overlap within the training data to look how it worked basically. And as you can see, I'm calculating here the character error rate. I'm using the predict. So right now we can see that I'm not loading the configurations of the vocabulary because it's already handled by this model. So I simply use it image to word model, read it from the given path, and everything is handled for me. I simply need to construct this kind of predict function that I use a resize image, I expand the dimensions, and I run the inference, and I need to decode the output. And basically, if I go, for example, into this basic object, you can use it without TensorFlow or Torch installation. You simply need to install my ML2 package, and so this will help you when deploying your models. And basically you can see here that I have here a metadata. If the model has a metadata, load this into this kind of object and it will have it. So for example, my metadata was vocabulary, so it saves it into the vocabulary, and that's it. So not to wait too long, let's run this kind of inference, and you'll see the inference. This will be a progress bar and a lot of strings. I'm not showing my images right now because you already saw these images in the training from the training dataset. Well, simply they are very similar images except that they have different strings and outputs. So let's wait it to finish this, and we'll see what character error rate we receive, and we might analyze this further. While waiting, I really encourage you to like this video, share this video, subscribe to my YouTube channel, and if you think that this video is helpful or will be useful for you or others in the future, don't hesitate to share it with you. If you have any questions, suggestions, here is a section below this video. You can write anything you want or simply do anything you want. So my video tutorial is published on my website. That link is also in the description, code is in the description. And I really encourage to try out this ML2 package that is on PyPy. And I believe right now I'm using a version of 1.0.2. No, but I need to increase it, and I'll make this release pretty soon within this tutorial. So it already finished, so let's go back and we'll see. And if you are interested to run simply inference on one example, you don't need to make this loop. Simply read your image and give it to the model. It will resize it everything according to the input requirements, and that's it. And as you can see, we achieved 0.09 average character error rate. Well, with TensorFlow I achieved it 0.06, but this might be the differences in the model, in the learning rate, and the batch size. Well, I'm not sure why it's different, why it's worse, but I believe that it would be possible to achieve same accuracy because, well, also we can implement way better model. Right now my model is very small and don't have a lot of parameters, and I'm using this for this tutorial, for basic tutorial, for learning purposes, or etc. So as you can see, we have here, let's look at the mistakes. For example, there was a word maybe, and we prediction as mainly. I don't know what that's. There is, for example, surprised, and prediction was suppressed. That are silly mistakes that could be solved with a better model. My architecture is from my mind. I didn't took any open source implementation suggestions what model I should use. So that's it. So that's it about this tutorial. I hope this was useful for you. You can use it whatever you want, and don't hesitate to share, subscribe, like, and we'll see you in our next part. I'll continue with this ML2 package that will help me a lot in the future, and I suppose for you too, if you're gonna learn how to use it. Thank you again for watching, and we'll see you next time. Thank you. Bye.